Today we're going to look at how to determine a probability model for a chance process and how to use some basic probability rules, including what's called the complement rule and the addition rule for mutually exclusive events. Okay, so imagine that you're flipping a coin 3 times. And I want you to stop the video for a minute after I explain here and make a list of all the possible outcomes of this activity. Alright, so you've had a chance to do this on your own. Let's see what you came up with. Okay. So the first thing, you know you're going to have heads. You have heads or tails on the first one. Well, you could have heads and followed by another heads, or heads followed by a tails. Okay. You could have tails followed by heads or tails followed by tails. And now you've also got that you could have heads, heads, and then you could have heads again, or you could have heads, heads, and then tails. You could have heads, tails, and then tails again, or you could have heads, tails, and then heads. And down here you could have tails, heads, followed by heads again, or you could have tails, heads, followed by tails. You could have tails, tails, heads, or you could have tails, tails, tails. Those are the 8 possibilities of what you could get if you flipped a coin, fair coin, 3 times. Okay? You knew there were 8 because the first one there were 2 possibilities, heads or tails. Second flip there were 2 possibilities. Third flip there were 2 possibilities. 2 times 2 times 2 is 8. That's how we can know that there were 8 possibilities there. Okay, sample space. Sample space is just what you just did. It's a list of all possible outcomes. It's a list of all possible outcomes. Alright. A probability model is just the sample space S along with a probability for each outcome. Okay, the probability for each outcome. Well, let's look at an example of a sample space. Rolling 2 dice, something you probably know, have some experience with. Rolling 2 dice. The sample space for rolling 2-sided number cubes is shown at the right. So this is our first dice, and dice 2. And we could get a 1 and a 1. Okay. Could get a 1 and a 1. Could get a 5 and a 4, or a 3 and a 5, or a 1 and a 5. Various things that we could get when we roll the dice. Okay, that would be the sample space. So there are 36 possibilities. 6 times 6. 6 on one dice and 6 on the other. So each outcome has probability 1 over 36. When we do this, we consider the outcome. For example, we have the outcome 5-1, and then over here we have the outcome 1-5. Those, those are 2 different possibilities when we're calculating the probability. They're 2 different outcomes, even though they add up to the same thing and they would look the same, especially if the dice are the same color, but they're actually 2 different possibilities, okay, 2 different outcomes. So we would say, if we wanted to say the probability, we'd say P of getting a sum of 7. Well, you can see here, here are the outcomes that give us a sum of 7. There are 6 of them, so it's 6. There's a 6 in 36 chance that you get a 7. Well, that's an example of an event. An event is simply any collection of outcomes. from a chance process. So we might have the event, and we usually label them with letters, capital letters. A might be a sum of 7 that we just used. B might be a sum of 9 on the 2 dice. And C could be a 2 showing on either die. Those would be 3 events. And we can calculate probabilities. We already talked about the probability of getting a sum of 7. The probability of B, well, we've got 6, 3, 5, 4, 4, 5, and 3, 6. There are four things that give us that. It's 4 and 36. There's a 4 and 36 chance of getting a sum of 9. Now the probability of C to have a 2 showing on either die, we've got, let's erase some of these probabilities here and we can use it again. We've got all of these have a 2 showing on 1 die, and all of these have a 2 showing on 1 die. Now that one we don't want to count it twice, so we got 6, 7, 8, 9, 10, 11 ways to have a 2 showing. So there's an 11 of 36 chance that a 2 is going to show up on one of the dice. Okay. Now, we can also calculate things like the probability of B or C and the probability of B and C. So take a minute and figure out for yourself those probabilities and then come back to the video. Alright, so you probably calculated the probability of B or C, which would be the probability that it adds up to 9 or there is a 2 showing. Adds up to 9 or a 2 showing. Well, adds up to 9, we've got those 4, and then a 2 showing, we've got the 11, all of these, and all of these. And so 11, there's 15, there's a 15 and 36 chance that you'll either get a sum of 9 or a 2 will be showing on either dice. What about the probability of B and C? What's the probability that you're going to have a 2 showing on either die, or you're going to get a sum of, and you're going to get a sum of 9? So a 2 showing and a sum of 9. So if we look back at those ones with the sum of 9, we had 6 and 3, 5 and 4, 5 and 4, 4 and 5, and 3 and 6. Those were our ones. We didn't see, there was nowhere, it's not possible for us to have a 2 showing and get a sum of 9. The highest we can get with a 2 showing is a 6 and 2 or a 2 and a 6, which is, of course, that has a sum of 8. So it's not possible. So the probability of that happening is 0. Those two things cannot happen at the same time. You cannot get a 2 showing on either die and have a sum of 9. Those are called mutually exclusive events. There are 2 events that cannot occur together. There's no overlap in those events. Now I could have a 2 showing and a sum of 7, because I could have a 2 and a 5 or a 5 and a 2. That certainly can happen, but I cannot have a 2 showing and a sum of 9. So those events are mutually exclusive. Okay? And there's some special things that go with that, and we're going to look at some basic probability rules. Probability of any event that we do is a number between 0 and 1. 0 would be a no chance that anything occurred, that the event occurred, and a 1 would be it must occur. So there's many more opportunities where you have a 0 probability. Not very often do you have a 100% probability. Second thing is this. If the sample space is S, then the probability of S equals 1. In other words, if you have to have something in the sample space. You can't get something out of the sample space. And the probabilities of all outcomes in S add to 1. Can't have it add to more than 1 or less than 1, because if it's less than 1, we're missing something from the sample space, and we can't have probabilities that are more than 1. Okay. So if events are equally likely, so if your 2 dice are fair, then all 36 outcomes are equally likely. Then the probability of an event, call it A, whatever, is the number of outcomes in A, whatever the event A is, over the total number of outcomes. Now we saw that in action. We saw that in action back when we did our 2 dice. We did the sum of 9. There were 4 ways to get a 9, and there were 36 total ways, so the probability was 4 over 36. So a lot of that is intuitive. Okay. The complement rule. So C is the complement of A. Essentially what it is not A. Everything that is not A is the complement of A. So if we talk about rolling a sum of 9, the complement of that would be rolling anything but a 9. So if our event A is rolling a 9, A complement is rolling anything but a 9. And it would make sense then that the probability of A complement equals 1 minus the probability of A. In other words, when we talk about the probability of A here, we know it's 4 out of 36. Well, the probability of not getting a 9 would be 32 out of 36, which certainly makes sense. And the addition rule for mutually exclusive events. It says this: the probability of A or B equals the probability of A plus the probability of B. In other words, I just add the 2 probabilities. If they are mutually exclusive events, we can just add the 2 probabilities together, and that gives us our new probability. We've also seen this. We saw this in dealing with our dice as well. So if we go back for a minute, we said the probability of B or C right here is 15 over 36. Well, the probability of C was 11 over 36, and the probability of B was 4 over 36. 11 plus 4 is 15 over 36. So we did that before we knew the rule. All right. Let's look at this example. So randomly select a student who took the 2013 AP Statistics exam and record the student's score. Here's the probability model. Show that it's a legitimate probability model. So our solution, A, first of all probabilities are between 0 and 1. That's one requirement. The second requirement is that 0.235 plus 0.188 plus 0.249 plus 0.202 plus 0.126. That has to equal 1, and it does. So all the probabilities have to be between 0 and 1, and the probabilities have to add up to 1, and they do. Okay? And find a probability that a student scored a 3 or better. So a 3 or better would be those 3. Now they are mutually exclusive. You can't score 3 and a 4. If you score one, you can't score the other. So they're mutually exclusive events, so all we do is add the probabilities together. Okay, so if we take 0.249 plus 0.202 plus 0.126, we get 0.577. So about 57% of the people who take the AP test passed it in that particular year.